Welcome to Lab 1 of Phoenix Part 1, Virtualization Fundamentals. In this lab, we shall understand the underlying commands to perform add, moves, and changes to Docker containers. Objectives. We shall explore many commands that will assist us in the following. First, the student will understand how to get the profile of a container, primarily the who, what, and where of the container in question. Next, inspecting the container, that is, review the makeup of the container and its contents. Next, understanding container management. Students shall be able to view the network of the containers, list the containers, attach to a container, or even execute a command within a running container. Then, we will demonstrate start and stopping containers. Also, understanding restarting a stopped container. Even run a container in the background or in an interactive mode. And finally, even killing a container process. Finally, the students will understand how to build a container. That is, build it to specifications, commit the container as an image, and push the container image into the registry, and even export the container as a tar file. As we begin with the lab in the attack and defense utility, we find ourselves in the Docker Basics lab. Our first step is to pull down the menu and make sure we're picking the server that is closest to our location. In this case, it's the server US East. Next, we push the button Run. Please note, it takes time to load all the processes, about a minute or so be patient. Meanwhile, we may want to scroll down and look at the notes in the guidelines. Here, there's some distinctions that are made that may be important down the road. The Docker daemon, Docker client, and Docker compose are installed on the machine. Now, the Docker daemon is not running on the lab start, so we ask that you press that button. That will run the etc init docker start. And also, a private Docker registry machine is present on the same network in your environment. And as such, you won't be able to contact the main Docker registry out in the wild because you're not connected to the internet. Once the run command is complete, all you have left is to push the link button, and this will allow you to link to the terminal of the started container, and then you can proceed with the lab. I should advise you that yes, there's a delay here as well. It should take about a minute or so. Once it's up, you should have a normal prompt in a terminal. So the first command we shall explore is Docker version. Now, for some of you that are familiar with Docker, yes, there is a Docker-V that exists that'll give you a one-liner, basically a version and a build number. However, if you use Docker version, spell it out, Docker version, you'll get a treasure trove of information. As you can see, a variety of information is presented to you. Not only the version of the Docker engine, but then as well as the git commit, the build date, the architecture, as well as API versions, the engine version. I mean, the list is long and illustrious. So just know that that's available to you. The next command we shall explore is Docker info. This command displays system-wide information regarding the Docker installation. Information displayed includes kernel version, number of containers, and images. The number of images shown is the number of unique images. The same image tagged under different names is counted only once, kind of like how they do it when they size an image, even though there are several names, tags, and instances of that particular item. They only count the common denominator, which is the image that they are born from. Now, when you type in the command, as was stated, it is a system purview with regards to the information that's relayed in the standard out. Server version, storage driver, a number of containers out there, the whole library of plugins that are being used, whether Docker Swarm, which is the management application, is either active or inactive. And then as you go down, you'll get the kernel version, operating system, as well as the OS type, which is very useful. So this is something also available to the student to profile a given environment. Here we take a moment to clear the screen, so to make it more legible. Now the next command we should look at is docker pull. Specifically, docker pull is pulling the image from a registry, and the registry is located at a host name, which unfortunately is named registry as well, on port 5000, as described in the aforementioned guidelines that were laid out for us. What this command does is pull an image or repository from a registry database. To clarify, most of your images will be created on top of a base image from the Docker Hub registry. Now, Docker Hub contains many pre-built images, so you can pull and try without needing to define and configure your own. Subsequently, to download a particular image or set of images, that is a repository, we will use docker pull. So moving on, the next command we will review is docker images. This command will list images, specifically show all the top level images, their repository and tags, and their size. An image will be listed more than once if it has multiple repository names or tags. The size is the cumulative space taken up by the image and all its parent images. This is also the disk space used by the contents of the tar file created when you Docker save an image. Now, to be more explicit, with regards to the size calculation, even though an image is listed more than once, that is, if it had multiple names or tags, as with a command that Docker info does for the size parameter, the same goes for the image command. The same image tagged under different names is counted only once. That is, a single image identified by its matching image ID uses up the size listed only once. We follow up with another command called docker image ls, and this results in the same thing as docker images. And as such, there's no real difference between docker images, which is docker list of images, and docker image ls, which is docker image list commands in terms of functionality, but we thought you should be aware of them anyways. Continuing on, the next docker command, docker run, can be used with the same parameter as docker pull, that is the registry :5000 Alpine, basically calling out the host. So in order to use the command docker run tickdt, then the host name, this command runs a command in a new container. Specifically, the docker run command first creates a writable container layer over the specified image that you call out, registry :5000 Alpine, and then starts it using the specified command, docker run. That is, docker run is equivalent to the API call of containers/create, then calling the subsequent containers container ID/start. So, as for the option of tickdt, D stands for detached, which runs the container in the background and prints the container ID. And T of the DT is short for TTY, providing a pseudo TTY. Here you see their output is relatively small, but it does take time to pull the respective containers as well as the information that they provide. Downloaded newer image, and they identify the image as registry :5000/Alpine :latest. The next command is the same command, docker run, but this time we run it with the options IT. I, meaning interactive, it stands for keeping the standard in open, even if you're not attached to the container. And T, of course, is short for TTY, providing a pseudo TTY. And in this case, the container actually executes and allows us to jack into a bash shell that allows us to execute some OS commands such as who am I and a variety of other easy commands. Here we take a moment to clear the screen again to make it more visible. Now we can run Docker PS, which is just pulling out the processes associated with Docker, and this command lists the containers that are in play or active. We follow up with the command docker container ls, which lists the containers as well. And if you'll notice, there's no real difference between docker ps, process status, and docker container ls, which is docker container list commands in terms of actual functionality. They even allow for the same set of flags. So the only real difference between the two is the fact that Docker container ls is newer and at times may be more verbose than the Docker ps. So as you see, when you type in Docker ps as well as Docker container ls, they both have the container ID, image, command, which is the bin shell, and then the time it was created with respect to the current time, and then status about how long it's been active and other names that are associated with the container. Moving right along, the next command we explore is docker inspect, which returns low-level information on Docker objects. Specifically, Docker inspect provides detailed information on constructs controlled by Docker. Now, whether you performed a Docker PS or Docker container ls, you did get a result that identified, or I should say, revealed the container ID. As such, you could put that as an argument for the Docker inspect and then put in the ID that you received, and then you'll get an entire library of information about that particular container. Now, this output may be confusing to some. This is a JSON format, and this is kind of a unified, transferable, or I should say importable format for many other applications. So it gives you that in a JSON format, so I imagine it would be easily exportable. But the whole thing for the student that's searching to get information or profile the actual container, if you go toward the bottom, you get a variety of information about the network that the container is associated with, also including the hardware address, the MAC address. And then, of course, you get the gateway IP, the IP address, and a variety of other things that may be of interest, so network ID and endpoint ID. And these things are of first and singular importance when you're trying to profile a container. So we'll clear the screen again so we can move on. The next command in question is Docker container itself, which returns all the commands and their meaning to manage your containers, such as starting, stopping, pausing your containers, etc. Running the clear command again will allow us to have better visibility of the next command. Much like Docker container, which returns all the commands and meanings to manage your containers, so is true with Docker image. It returns all the commands and meanings to manage your images in the registry, such as pulling an image or pushing one into the registry. And of course, there's remove and save the image. Moving forward, the next command we'd explore is Docker network ls, which is listing all the items in the Docker network. And it'll return network ID, name, driver, and scope, which would be local in this case. And it should be noted that the client and daemon API must be both at least version 1.21 or better to actually have this command work. And so use the Docker version command on the client to check your client and daemon API versions, so you'll know whether this command will even work. So you look at the items or the network that the command lists out, and you'll see that there are a few images out there corresponding to this particular environment. And then they tell you whether it's bridged or hosts or null as far as the drivers that are connecting the to the network, and then the scope all being local. Now we move on to the next command, which is on a similar note, Docker network by itself, which returns the commands available to manage the networks. In other words, connect, create, inspect, etc., etc. And it should be noted the version must be at least, of course, again, 1.21 or better to use this command. The next command we explore is Docker attach, which attaches local standard input and output and error streams to a running container. Specifically, this allows you to view its outgoing output or control it interactively as though the commands were running directly on your terminal. The format being Docker attach with any options and the name of the image you're shooting at or a container. And usually you would just use the container ID or the name of the container. On a similar note, as with Docker attach, which redirects standard out, input, and error streams to your interface from a running container, Docker exec is something that allows you to run a command on a running container. And so it only runs in the running container if the primary process, PID1, is running. Also, I should note that the command that you execute will run as long as the container is running, but if it's restarted, the container's restarted, your command dissolves. In this case, where we're running Docker exec and the options I and T, just to clarify, I is abbreviated for interactive, which keeps the standard in open even if not attached, and T is the abbreviation of the TTY, allocating a pseudo TTY. And then, of course, this example calls for the execution of bin shell, creating a bash shell in the host container. Now, the next two commands are combined only because they're very common to work together. You could take, first you would take Docker PS to remind you what the host ID is, and copy that, and then use it in Docker stop, Docker stop with any options and the container ID, and it will stop that container. And then you could restart it by Docker start and using that container ID as the parameter, and then you're good to go. So once again, as usual, we use Docker PS to remind us what the host ID is, and then use it as an argument to a newer command, Docker kill. And that will obviously just stop and kill the process that Docker is relying on for that container. And we will run clear screen again to make sure we have a clear field of view. Now, before we proceed to illustrate the new command Docker build, some explanation should be made about what is the Docker file and its role. Well, for those of you who hail from a Unix world, they may remember a profile or configuration file called makefile, whereas make was the command that used the parameters in the makefile to take direction in how to go about compiling the executable. And so it goes for Dockerfile. Dockerfile is used for the command Docker build, to take the directions within the Docker file to compose whatever is required. As with make took from makefile, Docker build takes from Docker file and basically follows the instructions within that file. So we create a Docker file with contents by using the cat command and redirect to Dockerfile. That allows us to overwrite the contents of the Docker file and start typing whatever we want and then hit Control C when you're done, and the result is whatever you wrote in the Docker file. So in this case, we paste in some known script. In this case, we use from and then the image registry 5000 Alpine. And from is basically a command that is required for you to build an image. And just with this command, you can actually build an image just with from. But here we actually call out a specific image from the registry container that we've accumulated. That being said, we go to copy script, and copy allows us to copy a file named script and put it in the directory of root. And you could use copy or add, whatever you prefer, but either one will work just fine to place a file script in the subdirectory of root. And then we actually run a change mod and a +X, making the script file executable. And then to check the contents, we Control C to get out of it. And then we check the contents of the Docker file to see if it was saved by catting the Docker file. And then it shows that it's fine. Now, being that we introduced a file called script, which we not only placed under root, as well as changed its permissions to be executable, we have to put something in it. We have to create a dummy script. And by doing so, we use the same command, cat redirect to script. And then we put in text dummy script in quotes, Control C, and we confirm what's in it, and cat script, and there it is, dummy script, and we're good. And then we ls to make sure the file exists, script and Docker file both created successfully. And now we finally get to use the docker build command and point it to the new image of registry 5000/Alpine dash or tick mod, and basically the image modified. And so Docker build builds that image from the Docker file, which calls upon the script file to do fancy things with. Now we can confirm the result by Docker images, and it lists the images that we have mentioned before. And once confirmed, we can use the new command called docker push, which pushes an image or a repository, which is a collection of images, to a registry. Specifically, use docker image to push share your images to the Docker Hub registry or the self-hosted one, which we have in this particular exercise. So the next command is docker run. It can be used with the same parameter as docker pull, which is the actual image that you're calling out. And like, for example, docker run and -it registry 5000/Alpine and shell sh. This command runs a shell command in the new container. Specifically, the docker run command first creates the writable container layer over the specified image, which we call out registry 5000/Alpine is the image. And so it creates a writable container on top of that. And then it starts using the specified command, in this case, shell. That is, docker run is equivalent to the API /containers create, and then runs the API /containers and the ID and start. And as such, that's what it does. It builds a writable container on top of the image that we call out. In this case, the regular registry 5000/Alpine. And so it spins up a writable container on top of that. As the options IT, as you saw there, just a reminder, I stands for the instance of keeping the standard in open, even if not attached. And then T is short for the TTY, providing a pseudo TTY. Now, once in the shell, we can use cd to the root directory and make some changes inside the container by writing a sentence in the file called note using echo command. And echo want to save this change, and then of course a redirect which overwrites everything on note.txt, and as such it puts content inside note.txt. And of course we can run cat note.txt to confirm that it was retained in that file. So at this stage, we retrieve the container ID by the usual docker ps or docker container ls, and then use that ID as an argument in the new command here called docker commit. Now, particularly, this creates a new image from the container's changes. Specifically, it can be useful to commit a container's file changes or settings to a new image. This allows you to debug a container by running an interactive shell or to export a working data set to another server. And the new image is confirmed, of course, with Docker images. Next, for illustration purposes, we use the docker export command, which exports the container's file system as a tar archive. Specifically, the docker export command does not export the contents of volumes associated with the container. It only does the container's file system. If a volume is mounted on top of an existing directory in the container, a docker export will only export the contents of the underlying directory and not the contents of the volume. Just know that that's not what it's doing. Docker export, the format is docker export and options, and of course the container ID or the container name. And the options of -o is output to a file. In this case, we use alpine.tar rather than standard out, which is just playing it out to the screen. Now, all this is confirmed by the command ls-l, which shows the creation of the alpine.tar, which is listed all. The next few commands are of a removal theme. First, there's docker rm, which removes one or more containers. To begin, you would run docker ps tick-a to verify the container's ID or IDs. Then place those IDs as an argument for docker rm. Naturally, you'd run ps-a again to confirm their removal. Now the format would be docker rm with the option, in this case we use a, and then container or containers following with a space. The next command is very similar, only that it operates with images. You use the command docker rmi, which removes one or more images. First, to use this command, you would naturally run docker images to list all the active images in the system. Then use the docker rmi with the option tick-f to designate which image file you are force removing. Then follow up with docker images to confirm that it's actually been removed. Now, this command works just as well with an image ID rather than the repository name. Again, you would confirm with docker images. In the removing genre, you'll also notice that there is a command called docker system prune. And what this does is it's a ubiquitous command that allows you to remove all unused data in your system. Specifically, remove all unused containers, networks, and images, and optionally volumes. So use prune conservatively because it can do some sweeping stuff. This is something that if you have a large list of databases you're done and you only want the active ones to survive, that's how you do that. And option in the tick, the option A is that all stopped or unused containers are swept away. Right? Finally, for our last exercise, we will go ahead and build another image. And hence, we'll have to create a new Docker file. But first, we have to delete the old one. So we remove a Docker file with the command rm space Docker file. And as such, we go ahead and run cat redirect to Docker file. So then we can go ahead and place any series of commands until we hit Control-C and to preserve the Docker file contents. And of course, we can confirm with cat Docker file in the end. The items we're putting in this time are run apt-get update & apt-get install yes, and then sudo man db man pages, curl, NetTools, and SSH. So probably the most common use case for run is an application of apt-get because it installs packages. The run apt-get command has several gotchas to look out for. Anyways, combine run apt-get update with run apt-get, or I should say apt-get install, in the same run statement, right? That's where the ampersand comes around. Using apt-get update alone in a run statement causes caching issues and subsequent apt-get install instructions fail. For example, in this specific example, if we ran them separately and then later wanted to add them separately, Docker sees the initial and modified instructions as identical and reuses the cache from a previous step, regardless of how much time has elapsed. As a result, the apt-get update is not executed because the build uses the cached version. Because apt-get update is not run, your build can potentially get outdated versions, as well as perhaps the older versions of NetTool and SSH packages. So running apt-get update and apt-get install kind of forces the system to run the apt-get update first each time it runs. So I guess what you would call this is cache busting. It ensures your Docker file installs the latest package and versions with no further coding or manual invention. This technique is cache busting. And you can also achieve cache busting by specifying a package version. This is known as version pinning, for example. And so once all that's done, the cat contents of the Docker file is confirmed by just cat Docker file, and you'll see that it's saved. And so now we're ready to use the next command. And this command would be docker build. And in this case, we're calling out in docker build a -network equals host. And it just, and we name it test -Ubuntu. And this build is an image called test with a network configuration that of the host. That's what network, right? In other words, my network configuration will be that of the host. And I pull that from the Docker file. And then options are basically -tick-t, which is tag. And that allows you to call out the name optionally as a tag or a name:\tag format. And then we use Docker images once again to confirm our completion of the lab. Well, that concludes the Lab 1 of Phoenix Part 1, Virtualization Fundamentals. And hopefully you understand now the underlying commands to perform add, moves, and changes of the Docker containers. We'll see you soon.